Welcome back to our Python Quick Start tutorial. Today's topic is on File.io, which deals with reading from files and writing to files. Our lecture today is accompanied by another one of our Jupyter notebooks. Today is Chapter 4, File Handling. As usual, please go restart the kernel, clear all output, and make sure it's trusted by your browser for the best experience. So let's start. What is File.io? Anything that we write on our computer is files. Typically, we exchange data, we save data, we write data. In its simplest form, it's just a normal text file. So how do we do this? In Python, it works fairly easy. A file is considered like a paper binder. If you want to read it or if you want to write it, first you need to grab that file and open it. So we open that by the open command. The open command takes two basic functions, two basic arguments. First argument is a file name. File name is just like here, simpledata.txt. The second one is a parameter that tells us if we open the file for reading, for writing, to overwrite, to append. So basic operations. If we open the file for reading, we assume it's there. The trickiest thing is on the stuff, the file name. Different operation systems treat them slightly differently. The file name is something that some operation systems are case sensitive, some are not. Be very careful. If you see that a file name has uppercase and lowercase characters, copy them exactly that way. Otherwise, you may have issues when you take your code and move it to an HPC computing system. These are Linux systems. Linux is case sensitive. So if you're working on Windows, it works on your system. And then it says it cannot find the file once you go onto Stampede or any other Frontera, any other supercomputer. It's very common that you have uppercase, lowercase errors. It may look the same, it's not. So be careful about that. The other part is the extension. Files have extensions, but nowadays, in particular, Windows comes pre-configured to hide any known extension. So Windows may show this as the file named simple data, and somewhere, if you look in the Explorer, says it's a text file. It still saves the file name as simpledata.txt. It just doesn't show you the extension .txt. If you think you see your file, you try to open it in Python and Python says the file doesn't exist, you may not see that extension on Windows, but nowadays also in some settings on the Mac, you may want to go and configure in the options for your file browser to show all known extensions. It may help you greatly. That's the trickiest part on the entire File.io. In my eyes, get the file names right. The other part, somewhere here is your code where you want to deal with it. In the end, we want to close the file. Python is not strictly requiring you to close the file. So you can actually skip that step once Python terminates, the file closes. If you have a bunch of examples like I do here, where we open and close files, it is safer to close them, because if you have multiple files open, imagine you have multiple programs, multiple parts of your code accessing the same file. Who wins when you write? Okay, on Windows, you cannot even read a file while you're writing on it. That can be frustrating when you have processes running in the background. They may just fail because you have somewhere in an editor open that file to see it. On a Unix system, that allows you multiple access. It can go the other way. Now, who writes last wins. So always, if you want to write, open, write, and then when you're done with your job, close. Make sure that there is a clean slate on everything. Last but not least, what's that F? F is not the file. F is a pointer that points to that part on your disk where that file data starts. It typically also is a handle that contains the other information if it's for reading, if there's any conversion, etc. But for you, in the simplest form, think of F is just a pointer. Where is that file? Open says, yes, we flip it open, but the data is still in that file. And all the other operations are then done while we have that pointer to the file, what needs to be done. If you need to work with multiple files at the same time, simply think F is a variable. So if you have 3 files, it could be F1, F2, F3. If you have files where you read from, files where you write to, I sometimes call them input file, output file, whatever. So careful, F is just a variable. It's pointing to where your stuff actually resides. So how do we read a file? The simplest form is we read it all at once. So we just say, we open that. Now that we have access to that folder, say read that folder, it returns the entire thing as a list of rows. So every line in a file is one entry in a list. The entire file comes as data. So let's just try that here. Hey, that wasn't too difficult. This is the first line, the second line, and so forth. So there's the trap. It's a text file. This is a string, not 3 numbers as you may think there are. This is a string that just looks like numbers. This is a string that looks like numbers. So if you want to do some mathematics, we need to convert them. The other part is, what if this file is really big? Hey, that's a finite element output with 100 gigabytes. If you say read, you get the full 100 gigabytes into your memory. And I don't know what laptop you have. Mine does not have 100 gigabytes of RAM. So this is a strategy that works for small files. If you have big files, there's a different way of thinking of it. And that's why I brought that file pointer. Think of a list. The variable for a list is a pointer to the start of the list in memory. The file pointer, F, is a pointer to the start on the hard disk. But disk is a different medium than memory, but otherwise it's treated as a long list of something. So F can be treated as a list pointer. You can loop through a list by saying, give me the list for item in list. Remember the for loop, for item in list. The list is the file pointer, and item in the list is a line. So I like to call that variable line. I could call it X, Y, A, whatever. It's a variable. So for one item in F, we get something. And this little code just basically says increment a counter and print the line number, period, and then the line. So I'm doing this with the same file, and we see we get counter and content. And there is one more thing that looks different. If you compare this, it looks like there are 4 lines. If you look at this output, to me, this looks like there are 8 lines. 1 line from the file, an empty line. 1 line from the file, an empty line, and so forth. And the issue that we're dealing with here is that each line coming from the file has at its very end a new line character that says that's the end of the line, but that comes from the file. The print statement also prints this, and then goes in the next line. So now this line says jump into next line, and the print statement jumps into next line. So this going in the next line comes from line, and the empty line is then added by the print statement. So we need to typically work around that. And that's a common problem that we're dealing with, that invisible new line at the end. And there are two ways of handling this. One thing is, hey, line has a new line. The print adds the new line. And that variable, that what it adds is as an optional argument to the print command. And if I say end, the default is end is a new line. And I say, if you add to the print command, end is an empty string, that means do not add anything at the end, then the print command did not do its end. The other part is, if you want to process the data, then that end line at the end of the data can be confusing, and that's the other solution. Line is a string. If you check the manual page for string, it has a lot of methods, string methods. And the one that I need the most is strip. Strip cleans out on both ends invisible characters. That's white space, tab, and the new line, for example. And the strip function has additional options, rstrip and lstrip, that says clean out only the left end, that would remove leading spaces, and rstrip removes stuff at the end. So I'm using here line.rstrip. That rstrip eliminates the new line from the line, and I don't modify the print command. So this line.rstrip is a cleaned up line read from the file, and that works the same way. Hey, I think overall, not too difficult if you know the little traps. Now let's go. How do we save our stuff to file? What's the difference? The difference is, number one, when we open a file, we need to tell it that we want to write, not read. Careful, when you say write, that file is overwritten. If it exists, it wipes it. And that can be a bit frustrating if you just copy this and call that my data, my simple data or whatever. Boop, you've overwritten the data that I've given you. So careful, have a separate name. If you write, you erase what's there, and there is no undo. There's a different way. It's append A if you want to take the file that exists and add at the end of it. But write starts from the beginning. Here, I am executing a write command and then open for writing. And instead of read, I write. And one write statement writes one string. But if I want this in multiple lines, now if I keep writing just my strings, they keep adding up. That gets a very, very long line. You need to tell at the end of the string that that shall be the end of your line in the file. So I need to add that \n or new line character to the first line. So here I just write two strings into my file, and I close the file. That saves the file. A quick way to check how that file looks is I can execute a shell command. On Unix, it's cat. On Windows, I think it's the type command that shows it. Percent at the beginning says execute this on the shell, and I just say show me the content of the file mydata.txt. Again, that works for Linux and on the Mac. I think you need the type command on Windows to see the same thing. So we see I have 2 lines and the line breaks. That's what I had to add here as my new lines. If you are on Windows and you didn't get that to work, or if you're on a Mac, we could do it from Python. We use simply our code that we had above here, where I say we read a file, I copied this code, and the only thing that I need to change is the file name. So when I copied that code down to here, I just didn't write it that pretty. I removed the spaces. I open the file and I read it line by line. Then it's done in Python.